mv squared over r. Okay, now you can have questions where v is not given directly, but because this one is still part of rotational, okay, whenever an object is going in a centripetal in a circular motion, it is actually in a rotational motion. Okay, so you can still apply your v is equal to r omega. Okay, and apart from that, usually you will see that if you have to calculate velocity, suppose the distance is given, you know that velocity is equal to distance divided by time. Now when you look at circular motion, okay, going in a circle, if you start at this position, you go that way and you come back to your starting position, you call that one revolution. Okay, for one revolution the time is equal to your period. Okay, your period simply means what time does it take to make one complete cycle or one complete revolution. So if you look, since it's a circular motion, your distance now becomes 2 pi r divided by your period. And this is another important formula that you need to keep in mind when you are doing rotation, when you are doing gravitation problems on satellites. Okay. Okay, so this is a question from your final exam 2011. It says a 70 kg foundation student stands on the rim of the merry-go-round of radius 2 meters rotating at an angular velocity of 2 radians per second. What is her centripetal acceleration? So in this question you had to apply, you had to give understand the concept that your linear velocity is equal to radius multiplied by angular velocity. Okay, so centripetal acceleration you know is equal to v squared over r. Because v is not given directly, but the radius is given 2 meters and omega is given 2 radians per second, you can use this formula to actually find your acceleration. Okay, either you can find your velocity first using r and w, or what you can do is you can just say v is equal to r omega, so your formula becomes r omega squared over r, okay, which becomes r squared omega squared divided by r. This r will cancel with 1 there. Okay, what you are left with is that your centripetal acceleration is equal to r omega squared. So you just put in the values, 2 into 2 squared, you get 2 squared becomes 4 times 2 becomes 8 meters per second squared. Okay, after you have found that, the second question says, what is the minimum coefficient of static friction between her feet and the floor of the merry-go-round that would keep her from flying off? So the only reason that she is not flying off is because her centripetal force is equal to her frictional force. Okay, so that is how you go about solving the second part of the question. The only reason that she doesn't fly off is because her centripetal force is equal to her static friction force. Okay, how do you find the centripetal force? You know it is equal to mv squared over r. Okay, and how do you find your Fs? So since he's on a flat surface, okay, you can just use mu s multiplied by normal force, Okay, you know Fs is equal to mu s multiplied by normal force. Since he is on a, or she is on a flat surface, normal force will be mg. Okay, you'll see that the masses cancel out, and you have v squared over r, which was the same thing as your acceleration, which we found in the first part, 8 meters per second squared. So what you can do is, in place of v squared over r, you can just put 8, and you can put mu s into 9.8. You divide by 9.8, divide by 9.8. Therefore, your mu s is equal to whatever answer you get by dividing the two. Okay, 0.82 is your static coefficient of static friction. Okay, the other question is similar to what came in test 2 as well. This is also from 2011 final exam paper. Okay, it says a 600 kg satellite is in circular orbit about the Earth at a height of 6,380 kilometers from Earth's surface. Calculate the orbital speed of the satellite. Every time if it says calculate the orbital speed, the simplest way you can do that is you can say your gravitation force is equal to your centripetal force, and then you make V the subject of the formula. Okay, if it says find the force of attraction or the gravitation force, then you just need to find Fg. Okay, now if I draw this scenario, it's something like this, right? We have Earth here, and the satellite is in circular orbit from the surface of the Earth. Okay, so somewhere there the satellite is orbiting the Earth. Right? This height is given as 6,380 kilometers. Let's change that to meters there, so that means times 10 to the power 3 meters. Okay, now every time you have a question like this, the radius is always taken from the center of the Earth. Okay, inside the core of the Earth, from the center of the Earth. So for this, you should know that your radius of the Earth, okay, radius of the Earth is equal to 6.38 times 10 to the power 6 meters. This will usually be given in your exam paper. Okay, these constants will be given. Right? So your total radius is actually equal to 6.38 times 10 to the power 6 plus 6,380 times 10 to the power 3 meters. Okay, that is your total radius, and that is the radius that you need to use in your calculation. Okay, so you get about 12.76 times 10 to the power 6 meters. Okay, now when you try to find the orbital speed, you do g, mass of Earth, mass of satellite, over r squared, and this r squared is the total distance. Okay, that is your r. Okay. That distance. is equal to mass of satellite V squared over R. So from here you'll see mass of satellite cancels out, radius cancels with one of the radius. Your V is equal to square root of the whole thing, G multiplied by mass of Earth over radius. Okay, not just the first part, not just the numerator, it square roots the whole value. Okay, so next you put in the values for your G, okay, and mass of Earth, and divide that by this radius. Don't just use 6380 kilometers. You need to use the whole radius. You can also have a question where the velocity is given and it will ask find the height above the Earth's surface where the satellite is. Okay, so you'll go about finding this radius in the same way. But once you have this radius, then you subtract it from the radius of the Earth to actually get your height, because this value here is height above the surface of the Earth. Okay, so in the first part, if you put in the values for G, mass of Earth and radius, you'll see your velocity should come around 5590.98 meters per second. Okay. After you find the velocity, the second part of the question says the period of revolution. Okay, the period of revolution. So like I said, velocity is also equal to distance divided by time that we used, and we said that the distance was 2 pi r divided by period. Okay, if I make period of the subject of the formula, multiplied by period, okay, and I divide by velocity, this side as well. My period, the period of that satellite is equal to 2 pi r divided by velocity. Okay, again remember it's 2 pi and the radius is the total radius, 12.76 times 10 to the power 6, okay, divided by 5590.98. Okay, whatever answer you get, that will be in seconds. Okay, so when you look at problems on gravitation, okay, and you will have a question from gravitation in your final exam, these are the things that are important. Okay, you should know the formula for your Fg, which is Fg is equal to G mass of Earth, or m1 m2 over r squared. You should know Fc, centripetal force, is mv squared over r. Okay, and if it gives you a certain height above the Earth, okay, you need to add that height together with the radius of the Earth. Okay, don't just use the height to do your calculation, otherwise your answer will become wrong. Okay, you need to do this. You need to add those values together to get the actual height of the satellite from the center of the Earth. Then if the question is talking about period or revolution, then you need to know that your velocity is equal to 2 pi r. You'll see this formula is basically represents the circumference of the circle, or the circular orbit. Okay, so the circumference of the circular orbit is basically your distance covered. Right? I think that's all from gravitation. It's a very easy topic, and this is one place where I can get full marks.